Thank you, Sneha. It's an honor to be here, from the other side and not organizing. So thanks a lot for hanging out at the end of Sunday afternoon to see my presentation. I'm Oprea. I'm the European lead of the Vulnerability Coordination Center. And today I will talk about security by design in relation to the sins that Besides Munich has talked about, and basically what we can do to counteract on them. Security, and in relationship to security, reliability, are central elements of product development and of the product. However, how secure and how reliable do you think a product needs to be? I would like to argue that 100% is never the right reliability or security target. It's more than what your customers want or need, and it will be very expensive to achieve 100% security or reliability, apart from it being impossible. So what I am going to talk about today is how to adapt what your product needs, what the needs of your customers are, to the business risk. It will be a very high-level talk. I'm just going to scratch the surface, and I will have some references at the end to how you can look deeper into basically building security and reliability into your products from the beginning. Let me tell you a story. More than 11 years ago at Google in the Bay Area, where our headquarters are, there was a change in the Wi-Fi password of the on the buses that are connecting San Francisco to the Mountain View headquarters. And the team, who is the company that's running the buses, had emailed all the Googlers working in the Bay Area, a few thousand people, telling them the Wi-Fi password has changed. Please update all the devices that are connected to the Wi-Fi. Google has had at the time, and also still has right now, a system for sharing passwords, passwords that are for third-party systems. So, as you would expect, many thousands of people had tried to access that password manager and try to get the new Wi-Fi password. However, that password manager was created quite a few years back with a target audience of a few dozen people who were system administrators at the time. So when many thousands, or maybe even tens of thousands at the time, employees tried to reach the password manager, it became unresponsive. We are Google, so we did think about redundancy. There was a second replica. So when the first replica became unresponsive, all the traffic was redirected to the second replica. Bad idea, right? However, there was somebody on call. The on-call engineer was on the East Coast of the US and was very confused when they got paged about the issue, because in its previous 5 years of existence, the password manager had never had a problem. So what's happening now? The engineer kept cool, though. There was instruction, and it was a set of procedures that they could follow to restart the server. So they looked at that and realized they would need to a special card that they would need to take from a safe in order to insert it into a hardware security module, into an HSM, in order to be able to restart the system. There was no such safe on the East Coast of the US. There was one in Australia, and there was one on the West Coast, where the Wi-Fi password was being changed. The engineer on the East Coast managed to reach the colleagues in Australia, and they wanted to access the safe. But where do you think the key combination of the safe was? In the password manager that was now offline. However, the colleagues on the West Coast soon came online, and one of them actually knew the password of the safe, the combination of the safe. So they did manage to retrieve the card, they inserted it, and there were some blinking green lights, but nothing happened. They thought, okay, maybe this card is wrong, so maybe it's broken, who knows. The people in Australia, in the meantime, managed to get drills and actually access the safe and retrieve the other card. And they've introduced it in the HSM. They've noticed the same green lights. and they got a message that seemed pretty cryptic, that something about password, and it didn't seem like an error. However, it was an error that didn't communicate too much, and it actually meant that the card was introduced the wrong way around. So after about an hour, they did try to switch put the card the other way around, and then the blinking lights continue to remain green, but the server restarted and the outage ended. So what I'm trying to say with this story is that there's a subtle interplay between security and reliability. They both need to be centerpieces of system design. However, we need to be careful on how they interact. In this story, the system, password manager, was offline because of a reliability issue. It had bad load balancing implemented, and its recovery was basically amplified by additional security measures. So what can we do to learn from these mistakes and build security and reliability into products? Let's start with the security part. We need to manage risk. I was talking about adapting the profile of what your customers need and what your product wants to deliver to the business risk. We need to manage security and we need to manage reliability risk. On the security risk side, we should think about the people who should be at the center of product design. Who are the actors that are interacting with your product? Which targets might your business have? Which assets might your business have? And what might potential attackers want to get from that? So threat modeling is very important when managing security risk. Some assessments that you should take into account with regards to risk that I like to call out are that you might not realize you're a target. So, for example, Adobe in around 2012 had an attack where some malicious actors used their certificates basically to sign malware. Adobe is not a security company. They are known for software that is enabling creators. So they were not expecting such an attack. So think a little bit about what assets do you have and what might represent the target for the attackers. You should start with the basics. You might know that phishing is actually one of the most successful attacks that organizations use in order to retrieve information. This is where being savvy is important and a way to counter lust, one of the sins that was called out at the conference. Don't underestimate your adversary. You might have heard the story of where the NSA has gone great lengths to intercept routers, Cisco routers, on the way to the customers and add backdoors there. So you might be dealing actually with very powerful and resourceful actors that are trying to target you. Attribution is hard. This is a story related to Ukraine, which is when we were thinking about this, well, it was before the Ukrainian war. But I guess it particularly now makes sense where NotPetya was thought, the malware NotPetya was thought to be related to Petya. However, the attack that happened targeting Ukrainian citizens in the eve of a holiday there and targeting the particular finance software that was used only locally had nothing to do to the original Petya ransomware that had a global effect. So it's, I think it's not so important to know who the attackers are, particularly related to the fact that even if you might know who they are, they might not always be afraid of being caught. Because the criminal system, particularly internationally, might make it hard to actually catch them. So once you know what your security risk, once you have done threat modeling, you identified what assets you have and what targets particular actors might want to reach, what can you do to protect yourself? This is where I'd like to call out a few topics related to list privilege. And list privilege is a design strategy that can help you in many situations. So let's say that you might actually be upset at your company and want to steal something or want to add a backdoor. Would you do that? Would you get caught? Who would notice? Or what if you are working overtime and have been dealing for many hours or even days with trying to fix an outage? How many mistakes away, how many copy pastes away are you from actually deleting all the data or wiping something out? This is where designing for a list privilege can help in avoiding many such scenarios related to either targeted attacks or accidental mistakes. So when designing for a list privilege, one strategy is zero trust. So making sure that you are not making trust decisions and allowing for who is going to do what, is going to do something based on who they are, but also what device do they have, what do you know about their role, and making sure that the infrastructure is run with particular roles. Multi-party authorization, making sure that not only no one person can actually perform critical administrative operations. This will increase the price that an attacker has to pay when trying to get access an asset from your business. If it's already a second engineer that they would need to compromise, then it's already double the cost. So maybe they think twice before doing that. Auditing and detection. Looking at logs will give you insights into who has done what, for what reason, and will allow you to ideally detect malicious actions. And we are talking about how the recovery of the password manager has been slowed down by security artifacts. This is where not only having plans for how to recover from failure, but also testing them regularly is very important. So continuing to reliability. For security, we're talking about threat modeling and looking at actors, looking at assets, and what might represent a target. When talking about reliability, we're looking at error budgets. We said 100% is probably not achievable, neither from a security nor from a reliability perspective. So on the reliability side, we're looking at error budgets, where all stakeholders in the organization should have approved a service level objective, or SLO, reliability target as being fit for the product. This is where above a particular threshold, users are happy. They will continue to use your product. They will not call support. It's basically a level of happiness. Under that threshold, you should notice that there will be more bug reports. People might start complaining and stop referring to your product. It's a fuzzy topic to define, so I'll just go fast over an example. Bigtable, this is a large storage that Google is using. And there are actually two large use cases that we have. One is customers that are serving data, or applications that are serving data directly from Bigtable to customers. So these kind of requests need to be very fast. They need to be very responsive. The customer should not have to wait to receive an answer. The other scenario, the other types of applications that are using Bigtable are using them for large scale. For example, running map reduces on large amounts of data. And in this case, it's okay to wait. Like the request don't need to be answered very fast. So when we think about SLOs and error budgets, we actually have two very distinct scenarios where success is opposite, is antithetic between the two. In the case of the user serving or customer serving Bigtable, for example, the queues need to be always empty because we want to have the responses provided immediately. And in the throughput use case where we run map reduces over data, we want the queues always full because we want to have all the time more data that is going to be processed. So having an SLO for both use cases would be very expensive. So the way Google has decided to answer this situation is to have two types of data centers. Some data centers where there's high SLO of 4 nines, 99.99, for example. I don't know the exact numbers, but something along these lines to be able to answer requests very fast. And the other one where we have throughput data centers for Bigtable where requests are being answered on a much lower baseline, and then we can it's much cheaper to run a data center for throughput than it is for the direct serving applications. So continuing with reliability risk, we talked about design strategies for security. With regards to design strategies for reliability, in relationship to the designing for least privilege, you would be surprised, but or maybe not, but they are actually the same. We talk about zero touch, which is going one step further from zero trust. Zero touch refers to running infrastructure that humans don't have direct access to because we make mistakes, or maybe somebody has been compromised and actually has malicious intent. So we don't want humans to be able to modify the state of production directly, but we want them to be able to do that through tooling. Tooling allows for auditing and detection. This also allows for example, verifying how many resources do we need in terms of CPU or memory for running an application. Multi-party authorization is the same concept as with reliability risk, as with security risk. In terms of reliability, it has the advantage that a second person might be more careful in detecting potentially malicious, potentially small mistakes that the engineer changing production might not have thought about. And in terms of recovery, we need to design our systems so that we always expect that they will be failing, and they need to have a way to go back to a state where they can run, even though maybe there's less memory currently or a particular resource that's unavailable. So automation is key in each of these design strategies. There's only one part of what I previously mentioned that I'd like to shortly go deeper into, and that is auditing and detection. What does it mean? Reviewing all access logs and justifications to make sure they are appropriate. Basically, we want to know who has done what, for what reason, when, and what was the outcome. in practice, at Google, how we do this is that we try to use structured justification. So, for example, if somebody from support needs to access a particular customer case from cloud support, then they will always have a particular support ID that they will use a structured justification, and then we can connect basically through the logs what actions have been done in relationship to this particular ticket ID. What another key part of auditing and detection is who is the auditor. At Google, we have two types of audits that we're particularly looking into. One is when looking for best practices. So, for example, an SRE or site reliability engineering team might do weekly checks of when did we do break glass. Break glass meaning we requested additional access in order to perform a particular task. So think about it a little bit like doing sudo on production. So something like this is reviewed by the team so that we know how can we improve and change our tooling so that we don't have to do break glass anymore, but that we can run in the regular context that we typically have. And there's a second team that does auditing, and that is the central security team. Here is where we implement the larger detection capabilities, and we look at what events have happened, how are all the actions that were performed by these teams that don't have anything to do with each other, are they connected, is there potentially an attack that's happening, and so on. So a pitfall that we've noticed here is particularly the auditor missing context or being objective. So that's why we're trying through these two areas where we're looking at audits to make sure we don't have any gaps between the two. So to conclude, shifting security and reliability left. There's a lot of trade-offs between security and reliability. Only if we commit to the full life cycle will we manage to make better products. The more trust we put into the systems and into the products that we're using, the more secure they need to be. And the more we use them and we rely on them, the more reliable they need to be. That's very hard to do and implement after the fact, like once systems are running in production, and we have to follow up with many patches and so on. It's much more expensive to build security and reliability after the fact. With that, I'd like to conclude with a few resources that I mentioned you can learn much more from and go deeper into these topics. I'd like to call out diligence, and this is where the B-Sides team was talking about bringing people into the community and allowing for growth, and each business and each individual finding their path into cybersecurity or potentially a security career. I think you've seen also many sponsors here looking into hiring people. If you're new to the cybersecurity or security, information security community or potentially career, you might know it's not the easiest to start from. But there are many people here who hopefully you can reach out to. Hopefully businesses learn that they should provide mentorship. They should be open to people joining, maybe changing careers, and so on. So I'd like to encourage all of you, either individuals who are looking for a change or companies looking to get more awesome colleagues, to think about what you can offer and give back to this community. And I also like to close by asking for a huge applause for the organizers. having been on the other side, I know how hard it is to make this happen. And I think you guys did a great job, so thank you. Questions?
Thank you so much, Anna. Any questions for Anna? Anyone? Yes.
Hello, Anna. Thank you for the presentation. This was awesome. One question I have is, so what I've usually seen in companies in my limited experience is that security is often some afterthought that happens after they think about reliability. Mm-hmm. So what often happens is security comes as a need later in the product lifetime, and so you're kind of forced to bake that in at some later point, not in the beginning. How do you usually handle that?
This is where I think there's a lot of potential in having the people responsible for reliability, be it sysadmins, SREs, DevOps, or even the developers themselves, and trying to get bringing security to the mind of the people responsible for reliability. It is very hard to take it at the end. You need to start with that because you might be in a position where you've had a breach or you've had ransomware or whatnot, and then you need to do something to stop the fire and stop the bleeding. Unfortunately, there's nothing around that. But afterwards, hopefully it will become more obvious to the business, and this is where you need to get the business on board to invest earlier, because it was very expensive to stop the fire last time. So what can we do to make sure we don't have a fire to put off next time? So bringing the security team closer to the developers and working together to teach them to bake security.
Make them more responsible from the security perspective.
Yes, and empower them, I would say. It needs to be not us versus them, because otherwise you've lost the battle. It needs to be us together. What can we do to improve the products and make a more successful business? Because at the end, we want to have a good product that somebody will use, buy for whatever reason.
Thank you.
Any other questions?
Thank you.
Thank you so much, Anna, for giving us the understanding and in-depth understanding of the fundamentals that systems must be fundamentally secure and not just superficially. Thank you so much. A big round of applause.